Hey guys, my name is Trevor Sullivan. I'm a solutions architect with StratusGrid, and welcome back to the StratusGrid video channel. Thanks so much for joining us for another video, and what we're going to be talking about in this video are Amazon SQS, or Simple Queuing Service, queue attributes. Now, there's a variety of different queue attributes that you can set on your SQS queues that change the behavior of messages that are being sent into the queue and being received off of the queue by consumer applications. So we're going to explore those a little bit. Before we get into that, I just wanted to briefly introduce StratusGrid. We are an ISV as well as an AWS Premier Consulting partner. So we have a product here called Stratosphere, which is a FinOps and security ops tool that helps you to manage your AWS cloud spend and find cost optimization opportunities. And we're also, as I mentioned, a consulting partner with AWS, so we can help do things like migrations and modernization, stabilization of your AWS cloud environment, and a whole lot more. So if you're interested in talking to us about any projects, feel free to hit Let's Talk up here, fill out this form, and we'd be happy to get in touch with you. Also, if you go out to our YouTube channel here, youtube.com/@goforthandcloud, I'd encourage you to subscribe to the channel to get any updates about future videos that come out, and also take a look at our historical videos here, as we have lots of different videos covering the Amazon Web Services Cloud platform. All right, now if you recall from our previous video here on our YouTube channel called Develop Rust Applications Using Amazon SQS, we introduced the basic functionality of SQS, how we can create a message queue, send a message into a queue, and then receive a message off the queue, and then delete that message off of the queue. So we kind of looked at the entire life cycle of getting messages onto the queue and then receiving them and deleting them off of the queue. But now what we're going to be doing is actually taking a look at something known as queue attributes. So if we head over to our SQS queue right here, I'm going to be working in the same queue that we used in the previous video. So feel free to reference that video if you don't know the historical context on it. And so I'm going to be in the US East or US West 2 Oregon region here. And the queue name is Trevor Sullivan 123. Now, if you drill into the SQS queue details right here and you click on the edit button, or actually you can expand more right here, you can actually see some of these attributes that describe the queue's current state, as well as some configuration options on the queue. So attributes on SQS queues actually have kind of a dual purpose. There are some queue attributes that are read-only that describe the current state of the queue, like how many messages are currently available on the queue, how many messages are currently in flight, and things like that. So that kind of describes what the current state of the queue is, and those are just read-only based on the actual number of messages in each of those states. But then there's also certain attributes that we can configure or change on the queue itself. So we have certain things like the maximum message size, that's a configurable value. We have the default visibility timeout, that's configurable. The message retention period is configurable. The delivery delay is configurable as well. So some of those attributes are actually settable or mutable on the SQS queue, and other attributes are read-only that just describe the current state of the actual queue. Now, if you click on Edit right here, this gives you access to change the configuration attributes that are settable, right? So things like the visibility timeout, the retention period, delivery delay, maximum message size, and receive message wait time, those are all things that we can configure. We can also change the configuration of message encryption for the SQS queue. We can change the access policy. We can also enable something called a dead letter queue. That's something that we haven't yet covered in one of our videos, but it basically allows you to reprocess messages and kind of send them off to a separate queue for manual intervention in case there are certain messages that are garbled and are not able to be processed properly. But we're going to primarily be focusing on these configuration options right up here. Now, if you want to change these configuration options, you can actually do that through the SQS API using code. So very similar to how we used a Rust application here to call things like the create queue operation to create a new message queue. We also did the send message operation right here to put a message onto the queue. We also looked at the receive message operation as well as the delete message operation. But on the SQS client in any of the supported AWS SDKs, including the Rust crate for Amazon SQS. There's also APIs that we can use to read the current attributes as well as change the attributes for configuration options on the SQS queue. So the way that we do that, if we take a look at the documentation right over here, there's an API called getQAttributes. And all we have to do is specify the queue URL, and then we can specify as an array which attribute names we want to retrieve right here. And then we can also call the set queue attributes right here, and that will allow us to specify which queue we want to set the attributes on, as well as specify which attributes we want to set. And when we set attributes, it's actually going to be a mapping here rather than just an array, because we actually have to specify the attribute name and then an attribute value that we want to change it to as well. So that's how we can read attributes and set attributes. Now, when we take a look at the getQAttributes API right here, you're going to notice that we can specify any of these attributes down here. And some of these are just going to describe the state of the queue. So things like created timestamp, that is simply a reference to the timestamp or the point in time when the SQS queue was created. So obviously that's something that's immutable. We can't change that because it's just inherent based on when the SQS queue was actually created. Also, the approximate number of messages that are currently on the queue, that's also something that we can read, but we can't change. So that's just based on the number of messages that are actually on the queue. Same thing with the number of messages that are currently in the delayed state. We'll talk about that as one of the configuration options in just a moment. But certain things can actually be read and changed. So things like delay seconds, that's something that we can read, but we can also change that if we go to set queue attributes. So if we go to set queue attributes, you can see that some of those things like the create timestamp are going to be missing because we can't change the creation timestamp. There's other attributes there like approximate number of messages on the queue that we can't change as well because it's just implicit based on the number of messages that we've sent into the queue. So what you're going to see are things like delay seconds that corresponds to the delay seconds. Where do we have that? I think that's the delivery delay right here. So then we also have the message retention period. We have the maximum message size. We have the SQS policy. So that's like a JSON policy that we can use to set access permissions from other services. We can also change the receive message wait time and the visibility timeout. So those are the core attributes here that apply to standard SQS message queues. Now, if you scroll down a little bit, there are some additional categories of attributes depending on the configuration of your queue. So if you have a dead letter queue configuration, there's going to be a couple of additional attributes that are available for you to configure that dead letter queue. We're not going to be talking about dead letter queues for now, but there are some separate settings or attributes that you can change if you are using dead letter queues. There's also certain options or attributes available if you're using server-side encryption. So we're not going to talk about those either, but there are some additional ones if you are using server-side encryption here. Also, if your SQS queue is a FIFO or first in, first out queue rather than a standard queue, then there are certain options that are available only on FIFO queues instead of standard queues. But in this particular case, the SQS queue that I am dealing with right here is a standard queue, not a FIFO queue. If you go to create queue here, you can actually choose if you want a standard or a FIFO queue. So that is what kind of determines if those FIFO attributes are going to be available or not on your SQS queue. But we're going to be focusing on just the core attributes here that apply to all message queues. So let's start by talking about the different options here. Let's go into my message queue right here, and we'll click on the edit button to edit the configuration of the queue. And the first thing we're going to take a look at is the visibility timeout. So the visibility timeout is a number of seconds between 0 seconds and 12 hours. And if we do a little bit of basic math right here, we can figure out what the maximum number of seconds is. So if we say 12 hours times 60 minutes per hour times 60 seconds per hour, or per minute rather, then the maximum value is going to be 43,200 for this particular setting right here. Now, what exactly is the visibility timeout? Well, if we take a look at the info right here, it basically tells you that the visibility timeout is the length of time that a message that has been received from a queue by a consumer application will not be visible to other consumers. So essentially what this does is when our consumer application pulls a message off of the queue, that message is temporarily marked as invisible. If you remember from our Rust code over here, we read a message off the queue by using the receive message operation. So as soon as we call receive message and we get one or more messages off of the queue, that visibility timeout gets triggered, and that message, or all of the messages that were returned as part of the receive message operation, are now invisible to other consumers, because we don't want other consumers to get duplicates of the same message that one consumer is already processing, right? And so what that does is it gives the consumer the period of time in order to process that message and then delete it off of the queue. And so generally speaking, depending on your workload, you're going to want to make sure that the visibility timeout is set to a reasonable value to make sure that each of the consumer applications is receiving the message off the queue and that that message is being hidden from any other consumers, so that those other consumer instances that are running as part of maybe an auto scaling group or additional containers or basically just other instances of your consumer application, they're not getting duplicate copies and they're able to get new messages off of the queue and actually continue processing new work as opposed to existing work that's already been pulled off of the queue. Now, what happens if something crashes during that timeout period? Well, if a consumer application pulls a message off the queue with receive message, and then for some reason that instance of the application fails before it's able to call the delete message operation here, then what's going to happen is after this visibility timeout window, which in this case is 30 seconds right here, after that 30-second time period, the message will actually be marked as visible again on the message queue. And so then another instance of a consumer can pick up that failed message and it can process that message once again. So that visibility timeout is there to make sure that each instance of your consumer application has enough time to process each message on the queue. But if something fails during the processing of that message, the message will be kind of put back onto the queue as visible to other consumers so that that message can be reprocessed or retried once again. So that's what the visibility timeout is here. And in the user interface, you can specify seconds, minutes, or hours. But again, the maximum value is going to be 43,200, which should be at 12 hours in seconds. So as you can see, we've changed that to 12 hours. But you're going to want to set that to a value that's appropriate for your specific application. So if you have, let's say, 30-second video clips that are being sent in to S3, and then you have an SQS message that just points to the S3 URL of those 30-second video clips, maybe you're building like a Twitter or Vine or YouTube Shorts type of application that you want to process these short little video clips with, then maybe your processor, your consumer application, typically takes, let's say, maybe 5 minutes to process or re-encode each of those video clips that's sent in. So what you could do is say, all right, well, my average time is about 5 minutes, but I'm going to say, let's just do 6 minutes here just to be safe. So if it's a little bit slower, we'll give it up to 6 minutes. But if after 6 minutes that message has not been deleted from the queue, then I want that message to be visible on the queue again, because I'm going to assume that it failed and another instance of my consumer application will be able to receive that message with another receive message API call. So that's the whole purpose of the visibility timeout there. You'll want to think about your consumer application, how long it typically takes to process a message before you delete it from the message queue. Sometimes that could be seconds, sometimes it could be minutes, sometimes it could even be hours. So you want to be thinking about how long does it take my consumer to process those messages and then delete them from the queue. And then you'll want to set the visibility timeout to an appropriate value for your specific consumer applications. All right, let's talk about the message retention period next here. So message retention can be anywhere from 1 minute to 14 days. And the whole purpose of the message retention period is to determine how long a message can exist on an SQS queue. So when you send a message into a queue, that message's lifetime starts immediately. And then once the message retention period has expired, so after 4 days or 48 hours, then that message that was sent to the queue 48 hours ago is going to be jettisoned from the queue, right? So that message retention period needs to be set to an appropriate value for your application to make sure that you're not losing messages, but you also don't want your message queue to grow really, really super large and have lots of messages that are never actually getting processed, right? So you want to have a reasonable retention period to make sure that messages are getting processed, but you want your queue to just continually get larger and larger and larger. At some point, you're probably going to want to clean up older messages from that queue, and that's the whole purpose of the retention period here. So you can set it from anything from 1 minute to 14 days, or if we take a look at the set queue attribute API right here, and we take a look at the message retention period right here, it can be an integer representing seconds, anywhere from 1 minute, which is 60 seconds, all the way up to 1,209,600 seconds, which is 14 days. And the default value is what my queue is currently set to, which is 4 days, which is 345,600 seconds. So that can be changed arbitrarily whenever you want. And as you may have noted there, it can take up to 15 minutes to actually apply that change as well. So just keep that in mind when you do make that change. So if I want to change my retention period and say, you know what, any messages that are older than 1 day, I want to just get rid of those messages, I can go ahead and change that and then just save my SQS queue configuration. And now we have successfully updated it. So you want to be thinking about, is it safe to delete messages automatically, or do I need to make sure that I keep those messages around to make sure that every single message is actually being processed? And if it's very critical that you process every single message that comes into the queue, like orders, for example, if you need to process order data and make sure that no orders are lost, then you probably want to set this retention period to a much higher value, something like maybe 10 days, or maybe even the maximum like 14 days, so that messages are not automatically being deleted from the queue, and that you make sure that your consumer application instances have enough time to go out and retrieve and process all of the messages on the SQS queue. Now let's talk about delivery delay next. So delivery delay is a mechanism for you to artificially delay the sending of a message into an SQS queue. So what's really interesting about this is that when you call the send message operation right here, like we did in our Rust application in the previous SQS video, that send message operation by default is going to make a message immediately appear on the message queue. So for example, if we go over here to our SQS queue, and I was going to demo one of the other options as well that we already talked about, but I forgot to do that. But if we just send a message here like status grid is awesome, and we set the delivery delay, you can do it on a per message basis, or you can do it at the queue configuration level. So if we say send message, and then we immediately start polling for messages, we can see that that message immediately becomes available on the queue. However, if I go to my queue configuration here, and I change my delivery delay to something like, let's say 15 seconds, it can be anywhere from 0 seconds up to 15 minutes. But let's say that I change it to 15 seconds right there. So now my delivery delay is 15 seconds. And again, I can override that in the actual message send operation here if I want to. But if I say status grid is awesome, again, right here, I say send message, and then I poll for messages. Watch, we don't have the ability to poll for that message, right? Because we're polling, but no messages are being received. But after 15 seconds, that message will actually be made visible. So technically the queue does have a message on it, but it's just not visible until that delivery delay has expired. So now you can see that this message has showed up right here, and we can now delete it from our SQS queue. So if we go back to our message queue here, go to more, you should be able to see messages delayed right here. And so as you can see, it says messages delayed 1. It doesn't update immediately because we did delete that message off the queue. So technically it should be 0, but sometimes it has a little bit of a delay to it when you're running SQS. So in this case, it still says that there's 1 message delayed, but if we refresh after a little bit, you will eventually see that that goes down to 0. But you can actually, at any point in time, read the messages delayed attribute using the get queue attributes right here. And if we take a look at the approximate number of messages delayed, then that attribute is a read-only attribute that allows us to determine how many messages have been sent to the queue, but simply are not visible yet on the SQS queue. So again, that just gives you an option to allow temporary delaying of delivery to avoid overloading your consumers. If your consumers are, really heavily overloaded and you don't have enough processing power to process all the messages, then you can simply delay the sending of messages into the queue. So you can send them into the queue, but you can just make their visibility delayed by an arbitrary amount using that delivery delay option. All right, so that's the delivery delay. I also did want to show you the visibility timeout here. So let's bump it back down to 30 seconds really quick right here. And so with visibility timeout, what that allows us to do is to, let's say, send a message into the queue, like Stratus Grid. I'm going to change the delay down to 0 so it goes immediately into the queue. So we'll send that message. And then when we call receive message, so if we pull for messages and we pull that message off of the queue, that triggers the visibility timeout. So if I refresh this page and then try to pull for messages again, you're going to see that that message is not visible because its visibility timeout was started when we first received it before I refreshed this page, right? So that visibility timeout has to expire after that 30-second period in order for the message to be visible once again on the queue. So after that 30 seconds expires right here, you'll see that it pops up once again. So that's how the visibility timeout works. After that 30-second period, if the consumer application hasn't deleted it from the queue, then it'll just pop back onto the queue for another consumer to retrieve and process. All right, let's go ahead and talk about the maximum message size here. That's pretty self-explanatory. I'm actually going to bump my delivery delay back down to 0 really quick as well. So maximum message size is anywhere from 1 kilobyte to 256 kilobytes. And you'll notice that we only have the ability to specify kilobytes right here. So if I try to do like 1.2 kilobytes and try to save that, we're going to get an error down here saying invalid value for maximum message size. However, if you use the API set queue attributes to change that value, you can actually set it to an arbitrary number of bytes as an integer value. So if we scroll down here and take a look at the maximum message size, you can see that it's a positive integer anywhere from 1024, which is 1 kilobyte, all the way up to 262,144 bytes, which is 256 kilobytes. So if you want to set it to 1,177 bytes, you're more than welcome to do that, but you just can't do that through the user interface in the AWS Management Console. You actually have to use the set queue attributes API in order to change that configuration. All right, so what we can do to kind of test that out really quick here is let's go set the maximum message size to 1 kilobyte. We'll save that. And then we're going to go to send and receive messages right here. And you can actually put emojis in here. So I'm going to put an emoji in here, and I'm just going to send that message to my SQS queue. And if we pull for messages right down here, you can see that this message is 3 bytes in size. Now, if I take that emoji and duplicate it, so I have 2 emojis, and then pull for messages again, you can see that that second message is now 6 bytes in size. So every emoji that I add is 3 bytes in size. So what I can do is, let's say 2, 4, that'll be 12 bytes. If I duplicate it again, that'll be 24 bytes. Again, that's 48. Again, that's 96 bytes. And then if I duplicate it again, that's 192 bytes. So if we do send message here, that'll still work because we're still under that 1024 bytes size. So as you can see, we're at 192 bytes. So let's duplicate it again, and we should be at 384. We'll paste it in a third time. That'll give us, let's see, can't do math in my head here that quickly, so let's pull for messages. So 576 bytes. And if I take this entire thing, I'll just select all and then copy and paste that twice. So 576 times 2 is going to be more than 1024. So if I try to send message here, we're going to get an error that says that the message must be shorter than 1024 bytes. So we'd have to cut down this message to less than 1 kilobyte in order for us to send it. But if I take this exact payload here, which is 576 times 2, so basically 1400 bytes or so, if I go back and change the max message size to 2 kilobytes instead, and then go back and try to paste in that exact same payload, then you can see that that message is sent successfully into the queue. And if I pull, you can see that I've got a message here that's 1.13 kilobytes in size. So you'll want to think about what the maximum message size is that's appropriate for your particular application. Your particular payloads may be very small. They may just be kind of a JSON payload that has a couple of properties, like maybe first name, last name, birth date, social security number, that kind of thing. And maybe it only uses like less than a kilobyte of data. So in that case, you could limit it to 1 kilobyte in size, but you do want to make sure that your maximum message size is set to any value that's larger than what your application's maximum message size is going to be. Otherwise, your application could run into an error if it tries to send a payload that's larger than the configured maximum message size, as we just saw a moment ago. So make sure that you're not artificially constraining your application by setting that maximum message size too low. All right, let's go back to our queue configuration right here, and we have the receive message wait time. So let's go to info right here. And so what this is, it's the amount of time that polling will wait for messages to become available to receive. The minimum value is 0 seconds. The maximum is 20 seconds. And so what this allows us to do is to specify when we call a receive message operation, rather than instantly returning a result, if there's no messages on the queue, we can actually just have that HTTP request hang for up to 20 seconds and wait for a message to be put on the queue, and then it will return that message back to the caller. So rather than having to continuously call the receive message operation and get 0 messages, 0 messages, 0 messages, 0 messages, which is kind of wasteful of HTTP calls, we can say, all right, I want you to wait up to 20 seconds. So make a single HTTP call to the receive message API and wait for up to 20 seconds to see if you get a message back. And that improves the efficiency of your application because you're not continuously having to construct and send new receive message API calls every couple of seconds, right? So that's basically just a way for you to improve the efficiency of your application. All right, so that's pretty much everything that I wanted to talk about as far as the queue configuration goes. We can also take a look at how to call those APIs from our Rust application here. So what we're going to do now is just kind of switch contexts into Microsoft Visual Studio Code. And previously, our code was going out and creating a message queue. And then we take a look at the create result. If the create result is okay, then we basically send a message to the queue, and then we receive a message from the queue, and then we iterate over all those messages and delete them off of the queue. So what I'm going to do is comment out everything from the send message down to the delete message there. So I'm going to leave the queue creation in place, I think. So let me comment out this whole section. Actually, I'll leave the create result right there. And then I'll grab the queue URL because we're going to need the queue URL. So I'm just going to comment out this code right here. So let's see. I want to make sure I'm hitting the right curly brace there. So let's comment all that out. And I think that's correct. And so now what we can do is once we get the queue URL, remember that we can call create queue on an existing queue. So we can, run this application. And even though the queue with the name Trevor Sullivan 123 already exists, it'll just go ahead and recreate it, and we can still read the SQS queue URL from that creation result object, the create queue output object here. So after the queue has been created, what we want to do is go to the SQS client again, and let's do get queue attributes. All right, so let get attr result equal the result here, and then we'll do a .send.await right here. And we also need to configure this request. So what we're going to do is take a look at the documentation for getQ attributes right here. So let's go over to docs.rs right here. We're going to go to the SQS crate, AWS SDK SQS. Then we're going to look for the getQ attributes API right here. And let's go to the getQ attributes struct right here. Actually, let's go back to getQ attributes, and we're going to take a look at getQ attributes input right here. And then we need to specify the Q URL as well as the attribute names. So what we need to do is say .q URL, and we're going to pass in the Q URL that we already retrieved from the Q creation process right up here. So we'll just pass in that variable right there. And then we also need to specify the attribute names that we want to retrieve. Now, the attribute names are not going to be string values. In the Rust SDK, we actually have this special data structure called the Q attribute name struct. And so what we can do is simply reference that. Actually, I think it might be an enumeration. So let's go ahead and copy that and bring it back here into the documentation. And so this is an enumeration that has a bunch of different variants on it. And so we can simply specify these variants. You can specify all if you want to retrieve all attributes, or you can individually specify which attributes you want to retrieve. So for example, I could say .attribute names, and then I could say, getQ, the Q attribute name. And then I could say, all right, I want to know the, let's say, creation timestamp or created timestamp. So then we'll say if getAtterResult dot is okay, then we'll say print line, and then the Q attribute is, and we'll go ahead and do a debug output here, and we'll pass in the getAtterResult dot unwrap. All right, so let's put a semicolon right there at the end as well. And let's do a cargo run here and see what we get back. So we should get a getQ attributes output data structure. And sure enough, right down here, it says Q attribute is, and we have this getQ attributes output data structure. And the attributes field has some, and then it has created timestamp. So some just means that it does have a value. So then we have created timestamp, and we have the number of seconds that have elapsed since the Unix epoch, which is January 1st, 1970 at midnight. And I believe that's UTC. So that's just the number of seconds that's elapsed since that Unix epoch. And then that's the creation timestamp of the SQS queue. But that's the only attribute that we retrieved. So we could change this to a different attribute instead, just by changing it to, let's say, approximate number of messages. So we can see how many messages are on the SQS queue. So now the attributes that were retrieved as part of the getQ attributes output data structure says sum, and then we have approximate number of messages is 5. And if we go back over here and we put another message onto the SQS queue, we'll just say test and then send message. And then if we rerun our application here, now you can see that the approximate number of messages has changed to 6. Now, the other thing that we can do is to specify that we want all attributes. So let's just change this to all, do cargo run here, and that'll give us all of the different attributes that are available here. So we have approximate number of messages delayed, we have the QARN, we have approximate number of messages, approximate number of messages that are not visible based on the visibility timeout. We have the visibility timeout itself, which is configurable with set Q attributes, and a bunch of others here as well. There's also last modified, so if you want to check the last time that the SQSQ configuration has been modified, then you can check that. That's also the number of seconds that have elapsed since the Unix epoch there as well. And then we also have delay seconds down there, which is another configurable setting with set SQSQ attributes, or set Q attributes. All right, so that's how you can retrieve attributes using the API here. Now, if we want to change an attribute, let's take a look at that API as well. So let's do let set attr result equals, and then we'll do SQS client dot set queue attributes, and then we'll just do .send .await that we typically do with any AWS APIs here. And then what we need to do for set queue attributes, let's take a look at the set queue attributes Fluent Builder. Let's go over to here and say set queue attributes, and let's take a look at the Fluent Builder. Let's see, where do we find that? Let's go back and look for the set queue attributes input builder, actually. And then for the methods over here, we have the ability to set the queue URL. We have the ability to set attributes here as well. So under attributes, we specify a couple of input parameters. We specify the K, which is the queue attribute name. Again, that's the enumeration that we looked at before. And then we have a just string value that represents the value that we want to set for that particular setting. And then, of course, all of these attributes down here are the ones that we can apply. And again, there's more advanced attributes here for certain things like FIFO queues or encryption on queues or dead letter queues and things like that, but we're just going to focus on these core attributes that we've already reviewed. So for example, remember we talked about how we can change the maximum message size to a custom value anywhere from 1024 all the way up to 262,144. So if we wanted to set that to some arbitrary value, which we couldn't do through the UI because it's limited to just kilobytes, then we could say dot attributes, and then K is going to be the queue attribute name, and the queue attribute that we want to set is going to be the maximum message size. So let's choose that right there. And then if we wanted to make this a little bit shorter here, we could say use this data type up here. We'll say use this, and then we can take off the prefix right here and just shorten that up a little bit. And then the value right here is technically going to be an integer, but we're going to represent it as a string because that is what the API is expecting here. It's basically just anything that can be turned into a string. So what we're going to do is just say, how about 1,000, or let's say 11,789. Okay, so just some kind of random value. So that's about approximately 11 to 12 kilobytes, somewhere in that range. So now, if we save this program and then run it, we're going to change the configuration of the maximum message size, and then we're going to read it right after. We're going to read the attributes right after we change it. So if we take a look at maximum message size, it looks like it's still 2048 right here. There is probably a little bit of a delay, so let's just run it again. And it looks like maximum message size is still there. And I think it's actually failing because we never set the queue URL. So that was my fault. It's actually failing, but we're not doing any error checking, so that was kind of opaque to us. So if we take a look at the queue URL here and just set it to the queue URL variable right up here, go ahead and save that, and then do another cargo run. And let's go ahead and borrow it there, and then we'll borrow it down here as well so that we're not moving that value out of memory. Then we'll rerun our application here. And if we take a look at the maximum message size, you can see that it's now been changed to 11,789. So now if we want to change it to something else like 12,708 or 787 or something like that, go ahead and run the application again. And our maximum message size should now be 12,787. So we can do that for other attributes as well. So we could say dot attributes, and then we could say queue attribute name. And remember that we can't set things like number of messages because that's just based on the number of messages that are actually in the queue. But if we want to change something like the delay seconds to, how about let's change it to 23. And we'll check the current value. So the current value of delay seconds is 0 right down here. And so if we do a cargo run, then we'll change both of those attributes in a single API call. And the new delay seconds, see if we can find that right here. Now you can see that delay seconds is the value 23 instead. And of course, you can always verify that inside of the AWS Management Console. So if we just go down here to more, you can see that the delivery delay has been changed according to the set queue attributes API call that we made right here. Now, of course, we could add some error checking in right here and say if set error result dot is error, then we could say print line error occurred while changing attributes on SQS queue. And then if we omitted the queue URL, let's comment that out really quick. Like we had before, that was a bug in our code. If we try to run this, then you should see error occurred while changing queue attributes on SQS queue. So then, of course, we can come back here, fix our bug, and then rerun this, and then the error message will not be printed out. So feel free to implement some error checking in there if you want to. There's lots of different ways that you can do that in Rust, but this is just one way that you can accomplish that. So anyway, I hope that this video has been helpful to you. We really just wanted to kind of focus on some of the core SQS queue attributes that are available that you can read from the queue as well as set on the queue, and also how to use the APIs, set queue attributes and get queue attributes from a Rust application in order to read those configuration options, as well as set some of those configuration options as well. So thanks so much for watching. Again, please subscribe to the channel so that you get notified about future videos. Please leave a comment down below and let us know what you thought of this particular video and what other topics you're interested in seeing on our channel. Thanks so much for watching, and we'll see you in the next video. Take care.